January 17th, 1944, outside the Anzio beachhead, Italy. The mud of the Pontine marshes was a viscous, hungry beast, black and cold enough to steal the warmth from a man's bones in minutes. It was 0300 hours. The air was thick with the scent of stagnant water, decaying winter foliage, and the metallic tang of old cordite. Along the Gustav Line, and stretching across the perilous arc that contained the burgeoning Anzio beachhead, Sergeant Major Klaus Richter, a veteran artilleryman of the Wehrmacht for 7 long years, stood by his 10.5 centimeters Lew FH-18 howitzer. He knew the rhythm of this war, a slow, brutal minuet of fire and counterfire. They shelled, they waited. The Allies shelled back, they ducked, and then they moved. It was a tedious, predictable dance, where the survival of the gun crew relied upon the deliberate, almost gentlemanly pace of the enemy's response. Klaus had learned to read the Allied artillery. They were methodical, usually firing a few ranging shots, followed by a brief, heavy, measured concentration, a flurry of steel designed to harass, not necessarily to destroy. They were an army of plentiful resources, yes, but their fire control still felt European, deliberate. They seemed to value the certainty of a perfectly plotted firing solution over the immediate shock of speed. Klaus expected, tonight, to deliver his planned concentration on a newly identified forward supply depot, reel his heavy piece back into the cover of the olive grove, and wait perhaps 45 minutes for the inevitable, somewhat scattered, American response. He would have time for a cigarette, a sip of cold coffee, and a quiet word with his crew before the first retaliatory shell arrived. The moment came. The command was given. The breech block slammed shut with a solid, echoing thud, a sound of martial comfort in the cold darkness. A blinding, orange-white flash erupted from the muzzle, tearing a temporary silhouette of the gun crew against the gloom. The deep, chest-rattling boom rolled across the Italian landscape, announcing the German position to the whole world. The 105mm shell, carrying Richter's signature of calculated aggression, began its journey toward the Allied lines. But this night, the rhythm was broken. The music stopped. Klaus had barely registered the recoil, the ringing still loud in his ears, when a new sound began. It was not the slow, whistling approach of the expected return fire. It was a rising, high-pitched screech, not singular, but plural, a terrifying, layered sound that was already above them. It was the sound of steel delivered not by calculation, but by immediate, digitized vengeance. And it arrived not in 45 minutes, but in less than 3. The first American shell did not land near them. It landed on them. It struck the ammunition stack stacked neatly behind the gun trail. The resulting explosion, a mixture of the incoming high explosive and the sudden detonation of their own stored propellant, was not just loud. It was final. The blast picked up the 1.5-ton howitzer and twisted it into an unrecognizable sculpture of shattered metal. Klaus Richter, the veteran who knew the tempo of war, did not even have time to utter a prayer, let alone light his cold cigarette. The unexpected speed of his annihilation was the opening act of a new, horrifying form of war, the war of computational fire. Historical context: the forgotten revolution of the guns. For centuries, artillery had reigned as the king of battle, but its operational tempo remained stubbornly tied to the limits of human calculation. In the First World War, artillery tactics became a science of massive, prolonged bombardments, where guns fired in concentrations for hours, sometimes days, to pulverize targets. The counterfire operations of that era were often cumbersome, relying on painstaking, days-long analysis of sound-ranging data, the triangulation of the muzzle blast recorded by sensitive microphones. The goal was attrition, not surgical speed. By 1940, the Wehrmacht, having perfected the art of maneuver and the blitzkrieg, saw their artillery as an extension of their tactical thrust. They prized accuracy, conservation of rounds, and the ability to disappear quickly. German artillery was well-trained and often superior in initial precision. They had refined their flash ranging and sound ranging techniques, believing they possessed the necessary technological edge for the defensive battle they knew would eventually come. Their philosophy was rooted in efficiency. A few well-placed shells were better than 100 wasted ones. This was the ideology of scarcity, Born from the memory of post-Versailles military constraint and the vast, resource-intensive fronts they fought on. They expected the inevitable Allied response to be equally methodical, equally constrained by the need for meticulous, manual triangulation and the labor of plotting new firing solutions. They did not account for America's true weapon, abundance. Abundance of resources, abundance of computational power, and, most critically, an abundance of the most overlooked resource of the entire war, time. The American industrial machine, fueled by an inexhaustible supply chain, was not just producing tanks and planes. It was producing time. It was doing so by replacing human effort with mechanical speed. The German artillerymen, whether hunkered in the hedgerows of Normandy or dug into the volcanic soil of Okinawa, operated under the assumption that the process of finding his gun, calculating a firing solution, relaying it to the battery, and getting the shells airborne took a fixed, minimum amount of time, a window of safety, or the margin of movement. This margin was historical, rooted in the analog methods of war. The American military systematically, technologically, and violently eliminated that margin. The symbolic object that represented this revolutionary shift was not a weapon of spectacular violence, like the tank or the bomber, but a simple, elegant piece of engineering. The M3 gun data computer, the mechanized heart of the American Fire Direction Center, FDC. If democracy was defined by the relentless pursuit of optimizing human output, the M3 was its perfect metallic symbol. It was a compact, electrically powered calculating machine, bristling with gears and dials, designed to replace the laborious, often error-prone work of 6 men with slide rules, plotting boards, and trigonometric tables. It was the embodiment of the American philosophy. If a calculation is needed, delegate it to a machine and do it instantly. The technological edge, calculation, and consumption. The speed of American counter-battery fire, often documented to be under 3 minutes from German muzzle flash to Allied shell impact, was the result of a revolutionary, interconnected system that bridged the sensor-to-shooter gap faster than any previous military force. This was the moment the scientific warfare long theorized by pre-war strategists became a chilling reality for the Axis powers. The process began with the observers. While traditional flash and sound ranging remained essential, the Americans deployed them with a greater density and integration than their adversaries. Flash ranging teams, often operating specialized surveying equipment, immediately determined the compass direction and elevation angle of the muzzle flash. Simultaneously, sound ranging sections, utilizing arrays of sensitive microphones laid out in precise grids, registered the sound wave of the firing gun. These acoustic and visual measurements were then immediately transmitted, often by dedicated radio or field telephone lines, back to a central headquarters. For the Axis, this incoming data was the beginning of a lengthy, analog process. It required skilled, specialized officers to transfer the data to large plotting boards, paper maps on which the gun position was determined by the intersection of the triangulation lines. Correction factors for wind, temperature, altitude, and muzzle velocity had to be manually consulted in heavy, laminated firing tables, then applied via slide rules. Each correction added precious minutes, and each minute was a chance for the enemy to relocate. The German doctrine accepted this necessary delay as the cost of precision. The Americans, however, treated this process as an engineering problem to be solved with consumption. When the American data arrived at the Fire Direction Center, FDC, it was instantly fed into the M3 gun data computer. This machine was the nexus of the counter-battery response. The M3 was not a universal computer in the modern sense, but a specialized analog calculator. By turning a series of input dials, target coordinates, range, meteorological data, and ballistic information specific to the type of shell and charge being used, the operator could instantly read the necessary firing commands, azimuth and elevation. The machine did the complex trigonometric work of correcting for the Earth's rotation, Coriolis effect, atmospheric conditions, and the specific ballistic properties of the projectile faster than a human could sharpen a pencil. This was the core transformation. The M3, a product of American manufacturing might and computational drive, shortened the fire mission timeline from the German standard of 5 to 10 minutes for the most practiced crews to often less than 60 seconds of calculation time. The Germans relied on the brilliance of the individual officer. The Americans relied on the systemic velocity of the machine. The result was a psychological war of terror waged against the enemy gun crews. German doctrine dictated that after firing, a crew must move, or at least prepare to move. But the speed of the American response meant that the enemy had barely stowed their cleaning rods before the first terrifying whistle of the incoming retribution was heard. This technological superiority extended beyond the FDC. The American artillery units, particularly those supporting the infantry thrusts, were increasingly equipped with self-propelled artillery, most famously the M7 Priest and the M12 gun motor carriage, which carried the heavy 155mm gun. While the Wehrmacht had excellent self-propelled guns, the scale of American production meant that entire battalions could transition from travel to firing position and back to movement with unprecedented rapidity. This mobility, when combined with the computational speed of the M3 FDC, meant that an American battery could often finish firing their counter-battery mission and be driving away by the time the initial German firing team had even finished plotting their response. The theater of shock, North Africa, and the birth of the legend. The first widespread, shocking demonstration of this American computational superiority came not in Europe, but in the arid, echoing expanses of North Africa. In 1943, as German and Italian forces battled the newly arrived, fresh American units, they encountered a difference in artillery doctrine that felt less like an incremental improvement and more like a tactical quantum leap. The German artillery officer in Tunisia, accustomed to the controlled, sparse fire of the British and Commonwealth forces, which also valued precision but were often ammunition limited, was shocked by the sheer volume the Americans could generate, seemingly on a whim. At Kasserine Pass, where the Americans suffered initial tactical setbacks, the German commanders often dismissed the American artillery as undisciplined, wasteful, and inefficient. They saw the volume of fire as a sign of inexperience, but this interpretation was fatally flawed. The volume was not born of waste. It was born of industrial confidence. The doctrine, known as massed fire, was a strategic choice enabled by limitless supply. The American artillery was often less concerned with hitting a single gun than with plastering a wide area with such intensity that the surviving crew was neutralized by shock and the sheer impossibility of continuing to operate under a continuous, brutal rain of steel. However, the real terror was the counter-battery system. A German battery, having fired a planned concentration, would sometimes be hit so fast that the crews suspected treachery, that Allied spies must have radioed their position before the round even left the barrel. The truth was far more terrifying. A machine had simply done the work of 10 men. Lieutenant Colonel Heinrich Voss, commanding an artillery group near El Getter, noted in his after-action report the uncanny speed and unnatural concentration of the enemy's reply. He wrote that his gun crews began to suffer from a unique form of psychological fatigue, not just from the incoming rounds, but from the sudden, terrifying realization that there was no safe window. The moment they fired, they were already marked for death. The interval between fire and counterfire, the sacred space of the artilleryman, had vanished. This speed was dramatically amplified by another key American technological advantage, the proximity fuse, or the VT fuse. While the proximity fuse was a closely guarded secret, its effect was immediately apparent. When an American counter-battery concentration landed, the shells often detonated above the German positions, air bursting with devastating effect against open gun pits, dugouts, and exposed crews. These premature air bursts negated the protection of overhead cover and turned the simplest concentration into a shrapnel storm, maximizing casualties among men who thought they were safe because the shell was designed to burrow into the earth before detonating. The combination, computational speed for rapid target acquisition, and the proximity fuse for maximized lethality, turned the American artillery into an engine of instant, overwhelming destruction. The doctrine of abundance, a philosophical rift. The disparity between the two armies was not just technological. It was philosophical, reflecting two fundamentally opposing ideologies. The German and Japanese armies, especially as the war dragged on, operated under the ideology of conservation and mastery. Every round was precious, reflecting the reality of extended supply lines and shrinking industrial capacity. The goal was to achieve maximum effect with minimal expenditure. Their training emphasized precision shooting and the maintenance of intricate, well-organized firing data books. The human gunner and the calculating officer were seen as the indispensable masters of the craft, their skill irreplaceable. Their system was designed for the elegant, precise dueling of opposing artilleries, where the better-trained crew won the long game. The American ideology, underpinned by the symbolic machine. The M3 computer was abundance and velocity. The objective was not surgical conservation, but target neutralization through overwhelming force applied with machine-like speed. Firing tables were replaced by punch cards and gears. The human element was reduced to inputting coordinates and turning a crank. The doctrine prioritized getting the round into the air immediately, using the computational accuracy to ensure the massed fire hit the target area, regardless of the individual gun's perfect alignment. The American system was designed for the industrial destruction of the enemy's will to fight. This philosophical rift was most keenly felt in the Pacific Theater, where the Japanese, relying on deeply dug, camouflaged positions and the element of surprise, faced an even more terrifying response. Japanese artillery doctrine, influenced by a fierce spiritual commitment, relied heavily on the idea of the ghost gun, the ability to fire, disappear into the jungle, and fire again from a new, unexpected location, often moving the piece manually over grueling terrain. They expected the American response to be slow, predictable naval gunfire, or cumbersome infantry support. Instead, on islands like Iwo Jima and Okinawa, they encountered a devastatingly fast, land-based counterfire system that rendered the ghost gun irrelevant. The volcanic ash and dense jungle of the Pacific made flash and sound ranging difficult, but the Americans introduced specialized radar systems specifically for counter-battery fire. These radars, particularly the SCR-584, were originally designed for anti-aircraft use, but proved devastatingly effective at tracking the flight path of an outgoing mortar or artillery shell. By tracking the trajectory of a Japanese round, the radar could instantly project its origin point, giving the FDC, with its M3 computer, a precise location in seconds for the Japanese gun crew. The expectation of being untraceable in the jungle proved to be a deadly illusion. They would fire, and before the smoke had cleared from their own position, a storm of American shells, often guided by the same proximity fuses that plagued the Germans, would descend. The Japanese, who saw themselves as masters of camouflage and patience, were undone by a technological system that prioritized detection velocity over concealment expertise. Their patience was met with instant, unyielding violence. Transformation of the mind, the loss of sanctuary, the ultimate, long-term effect of the American counter-battery system was not just tactical. It was psychological. It fundamentally transformed the reality of the front line. Especially for the specialist, the artilleryman. An artillery crew is an army's nervous system, located behind the front lines, operating under the perceived safety of distance. They are the executioners, but they are also the most exposed to the enemy's revenge. The traditional mindset allowed them a moment of psychological decompression after firing, the window of safety. They needed that time to reload, prepare for movement, and steel themselves for the eventual reply. It was a cognitive gap that allowed them to rationalize the danger and continue their work. The American FDC, powered by the M3 gun data computer, our persistent symbol of industrialized calculation, systematically destroyed that gap for the German and Japanese crews. The act of firing their weapon became a literal act of self-exposure. The muzzle flash, once the proud signature of a successful mission, instantly became a beacon, a death warrant stamped by a calculating machine thousands of yards away. This immediacy bred a pervasive, crippling anxiety. Crews became hesitant to fire, knowing that the moment of illumination was also the moment of judgment. They began to fire fewer rounds, or worse, to fire and immediately abandon their guns, rushing to cover before the first shell arrived, leaving their valuable equipment exposed and their operational tempo shattered. This change was noted in the diary of a German non-commissioned officer, captured in the Hurtgen forest. We do not fear the barrage that falls minutes later. We fear the one that is already falling as our shell lands. It is a war without time, where the enemy knows your decision before you have made it. This sentiment speaks to the transformation. The enemy was no longer reacting to an action. They were reacting to an event that was over before the echo of the blast died. This transformation also extended to the Allied infantry. When an American or British unit was under fire, they had an almost sacred confidence in the speed and power of their own guns. They knew that within seconds of calling in the counter-battery fire, the enemy would be silenced. This confidence translated directly into greater aggression, reduced panic, and a sustained capacity to advance under fire, knowing that vengeance was both swift and technologically guaranteed. The counter-battery fire was not merely defensive. It was a potent psychological asset that allowed the infantry to focus on the objective, assured that the king of battle on the enemy side would be dethroned in moments. The final fronts, Europe and the overwhelming system. By the time the Allies pushed into France after the landings at Normandy, the American counter-battery superiority had become a well-oiled, standardized, and terrifying system. The German crews, particularly those veterans who had survived the Eastern Front, found a new kind of grinding horror in the West, the sheer scale of American resources, embodied by the computational speed, allowed for tactical luxuries the Germans could only dream of. For example, American meteorology teams were often dedicated to only providing up-to-the-minute atmospheric data, wind speed, pressure, temperature, which were constantly fed into the M3 computers. This provided an immediate, highly granular correction factor that ensured first-round accuracy, negating the need for multiple, time-consuming ranging shots. The German system, often relying on older, less frequent weather reports, had to rely more on observed fire correction, which took time and exposed the position to enemy spotting. In the close, confusing terrain of the Normandy bocage and later the vast plains leading to the Rhine. The American ability to generate effective concentrations, and more critically, to shift fire instantly from one target to another, was decisive. The M3 computer didn't just calculate one target. It could calculate dozens of targets for an entire battalion simultaneously. A request for fire support or counterfire could be relayed to 4 different batteries, each with a different type of gun and a different type of ammunition. And the M3 would instantly provide the correct, distinct firing solution for each piece. The result was the implementation of a doctrine called time on target, TOT, where multiple batteries, sometimes miles apart, synchronized their fire so that all shells, regardless of the distance traveled or the type of gun used, would land on the target simultaneously. This required an exponential increase in the speed and accuracy of calculation, which was impossible to achieve manually in the field. The M3 computer made TOT a routine, devastating tool. When a German position was hit by a TOT concentration, the impact was not a sequential series of blasts, but a single, seismic event, a terrifying, earth-shaking hammer blow that shattered both structures and human resolve. The German response to this computational terror was often a desperate reliance on heavier, longer-range guns, the 15 cm SFH-18, for instance, which could fire from deeper behind their own lines, lengthening the travel time of the shell and theoretically confusing the Allied detection systems. But even this was a losing game. The American SCR-584 radar, now being deployed en masse, was perfectly capable of tracking the longer trajectory of the heavy shells. And the computational speed of the FDC meant that the range was simply another variable to be instantly processed by the symbolic machine. Distance was no sanctuary. The counterfire found them just as quickly, only with a greater margin of error due to the increased distance, which the Americans compensated for with an even greater volume of fire. The sound of calculation, a symbol of democracy, our recurring symbol. The M3 gun data computer was more than a machine. It was the physical representation of the massive, unconstrained logistical and intellectual power of the United States. It symbolized a form of democracy that extended even to the battlefield. The democracy of speed. It was a machine born of a system that believed in replacing strenuous human labor with optimized technology. freeing the soldier from the drudgery of calculation to focus only on execution. The M3, clicking and whirring inside the relative safety of the FDC track, was a small, quiet revolution against the Axis ideology of relying on individual, highly trained genius and the conservation of scarce resources. The sound that accompanied this technology was the sound of the American self-propelled howitzer, specifically the M7 Priest, delivering its counterfire mission, rapid, rhythmic, and relentless. Unlike the staggered, booming, human-paced concentrations of the German guns, the American return fire sounded almost mechanical, a swift, continuous thump-thump-thump of multiple guns cycling quickly. It was the sound of the assembly line translated into war, where the enemy was not just fighting the man behind the gun, but the entire industrial base of a continent behind the man. The German artillerymen, standing in the mud and the dark, listened not just to the incoming shells, but to the pace of the enemy fire. They listened to the terrifying, inhuman speed of the reply and understood, in a visceral, chilling way, that they were not fighting an army constrained by the rules of old, but an entire industrial system designed for immediate, efficient, and overwhelming destruction. The short, sharp whistle of the incoming shell was the final, undeniable proof that the war had become a contest between conservation and infinite consumption, between manual skill and computational velocity. And in that contest, the side that could calculate the fastest and spend the most was the side that would survive. Epilogue. The geometry of freedom. The war ended, and the terrifying silence that followed the final salvos left behind a landscape scarred by the technological genius of conflict. The veterans of the Axis artillery, those who survived the maelstrom of counter-battery fire, carried a deep and lasting memory, the minute of judgment. They had been masters of the battlefield, only to discover that the battlefield had become a problem in mathematics, solvable by an enemy whose resources were not simply abundant, but computationally abundant. This speed, the instant negation of a threat, the ability to eliminate the distance between sensor and shooter, was ultimately a reflection of the larger truth of the conflict. It was the geometry of a free, industrial society, unleashed and focused on a single, technological objective, where one ideology conserved and rationed, the other spent and calculated. The M3 gun data computer, our forgotten symbol, was eventually retired and replaced by true digital machines. But the principle it established remains immutable. Freedom, when backed by the limitless capacity for innovation and industry, becomes the ultimate tactical advantage. It is not just the abundance of steel that wins, but the ability to calculate its trajectory and deliver it with machine-like speed, erasing the precious human moments of safety that the enemy had always relied upon. The German and Japanese gunners never knew, in the cold of the Italian marshes or the humid shadows of the Pacific Islands, that they were not merely fighting soldiers. They were fighting the clock, and the clock was being held by a machine built in a world of limitless possibility. That chilling realization, delivered by a barrage that arrived in minutes, not hours, was the final, devastating truth of the war, that the ability to calculate faster was the ability to survive longer. A profound, mathematical metaphor for the inevitable trajectory of the democratic world.